remember something from Alpha 1. So, solving systems of equations, just two equations. We're going to start with graphing today. Okay? Yesterday's lesson led us into this. Yesterday the difference was we took one equation in x, and we pulled it apart, made it two separate equations, and graphed those. Today, the difference is we're being given two equations right off the bat. So, let's start with our first equation. Negative 3x plus 2y equals 8. What can you tell me about graphing that?
It's going to be difficult when y equals mx plus b.
It's going to be difficult when it's not in y equals mx plus b. So what should we do? Should we switch it to y equals mx plus b? Yeah, that's always going to be my go-to method. Okay, there are some other methods to graph this. Okay, like my brain, I could do x and y intercepts, although the x-intercept would not be nice, so that's not going to be hugely helpful. But, you know, there are other ways you can do that. Easiest way, though, at our level is just always go for slope-intercept form. So, let's get y by itself. How do I want to get y by itself? What do we say? I've heard different things. Well, not to get it y equals mx plus b. Yeah. If we're trying to get y by itself, add over the negative 3x. So if we add 3x to both sides, so then I'm going to have 2y equals 3x plus 8. How do I keep going? What are you saying? Okay, if it's 2y, I want 2 by itself, or I want y by itself, so divide by 2. What does this equation read as we rewrite it? Okay, y equals 3/2 x plus, and 8 divided by 2 is 4, so I'm going to go ahead and put it that way. Okay, we've done this several times lately. I'm trying to get you guys to be pros with graphing y equals mx plus b, yes? Where's my y-intercept? Okay, y-intercept is 4. So on the y-axis, we're going to go up 4. And the 3/2 is my slope. What phrase are you using for slope? Rise over run. You've been with me at all lately. We've done this, haven't we? So from my point at 4, I'm going to rise 3, run 2. Rise 3, run 2. And keep in mind, that was going up 3, right 2. I can also reverse this and go down 3, left 2. Down 3, left 2. Down 3, left 2. Down 3, left 2. Like yesterday, I'm going to kind of go crazy with the points. But it's necessary because we need to know exactly where our line is. The rulers are over there if you want to use a ruler again, yes? And there's our first line. Okay. You guys got the first one? Ready for the second one? X plus 2y equals negative 8. What do we need to do to make this y equals mx plus b? Okay. Subtract x. So now I have 2y equals, you can write negative 8 minus x. However, we could also go ahead and say negative x minus 8 if we're trying to get set up for the next step. Then since it's 2y, we're going to divide by 2. Y equals, what about negative x over 2?
That should be negative 1 over 2.
Yeah. What's the invisible number in front of x? That's a negative 1, yes? So if that's a negative 1 and it's divided by 2, think of this as negative 1/2 x minus, what's 8 divided by 2? 4. Okay, so what do we know? Y-intercept? Negative 4. And slope? Negative 1/2. So I'm going to start with my y-intercept of negative 4, which says I'm going to go down 4. Okay, guys. How do I do a slope of negative 1/2? Rise over run. And options here include we could rise negative 1 and run positive 2, or we could rise positive 1 and run negative 2. Realize this if it's a negative slope, one of the numbers is negative, not both of them. So if I rise negative 1, that's down 1, run 2 is right 2. So we could go down 1, right 2, down 1, right 2. The other option is we could rise positive 1, run negative 2. So up 1, left 2. Up 1, left 2. Ooh, good things happening. Good things are happening, yes? Am I done? Why am I not quite done? I need an answer. We haven't given an answer. What's our answer? What'd you say? I need a little bit more than that. I agree. I'm not disagreeing.
Do you need the whole point?
Okay. So yesterday I only need the x because my equation only had x's, yes? Today my equations have x's and y's. So, well, it's true x equals negative 4. I need the whole point. And the point we're talking about, by the way, is the intersection point, yes? Mm-hmm. And so what is that? Negative 4, negative 2. And I'm sure Savas will say, express your answer as an ordered pair. That's their typical language there. Okay, what are you thinking? This is, as I said, this is Algebra 1. What's the tough part? I didn't give you the equations in y equals mx plus b form. That's the hardest part. Okay? But that's reality, isn't it? They don't always give us the equations y equals mx plus b. I love it when they do, but they don't. Okay, let's try the next equation, or next system of equations. X minus 2y equals 4. We want to graph this. What would you like to do first? Okay. Yeah. And we can do this a couple of different ways, but if we're trying to get the 2y by itself, we can subtract x. So then I have negative 2y equals, you can say 4 minus x or negative x plus 4. Since it's negative 2y, we want to Divide everybody by -2. What about this one? What's -x divided by -2? Yeah. Negative divided by negative is a positive. So if we think invisible 1 in front of the x again, it's a positive 1/2 x. And plus 4 divided by -2? -2. Okay. So, y-intercept of -2. Slope of 1/2. So with a slope of 1/2, we're going to what? Rise 1, run 2. And you can always reverse it. Down 1, left 2. Okay. Make sure your graph looks right. Connect your points. And other equation. 3x plus y equals 5. In order to solve this for y, we're going to subtract the 3x. And if we subtract the 3x, y is equal to, you could say 5 minus 3x, or I put negative 3x plus 5. Y-intercept of 5. A slope of -3. -3 is a fraction. Put it over 1, and it's -3 over 1. So, rise over run. Rise -3. Run 1. Rise -3. Run 1. Oh, there we go. I found it, didn't I? Down 3, right 1. You can also reverse it and go up 3, left 1. Okay, I can't handle that. Okay, it's just gonna look bad.
Maybe it's just because you ran 2.
Yeah, you went 2.
What did I do?
You went left 2 all the time.
That's why I can't get it right. I knew something had to be strange. Okay. I was like, something's not right here. Okay, so this point is in the wrong spot. Okay. I thought it was maybe just because I made my y-intercept like a ginormous point. I thought that's what was throwing me off. Now I'm just... Okay. Better. Okay, enough. Answer.
2 -1.
You guys, everyone agree? Cross right there. Word pair. 2 -1. So when you're asked to graph in homework, you graph one line, you graph the other line, you give the answer, right? This is not a Desmos activity. This is a figure it out. I'm curious. Huh. I don't know. I've never tried if Desmos has to be y equal or if it would graph something not in y equals.
They have the Y button, so we should get all that afterwards.
Yeah, I don't know. Interesting. Okay, one of our three methods from Algebra 1 was graphing. Probably the one we use the least, but it's the idea that we're looking for where the one equation meets the other equation, where they cross, right? Okay, method 2 that I'm going to teach is substitution. And it'll probably mean, if I had to guess, elimination will end up Monday, maybe. Personally, I usually prefer elimination over substitution when I can use it, and I feel like it usually teaches better, but they all have their own times that we need them. So we're going to talk substitution. When we talk substitution, I always ask you to start off looking for an equation that is either in the form of x equals or y equals. Okay, so you're always trying to find or create an equation that's x equals or y equals. Once you have that equation that's x equals or y equals, we're going to do a substitution. So, do I have, in this first example, an equation that's x equals or y equals? Yeah. We have one that's y equals 7 minus x, right? So it's y equals. So what we're looking at here, since it's y equals 7 minus x, in the bottom equation, every place I see a y, we're going to replace it with 7 minus x. Since y is equal to 7 minus x, every place I see y, I'm replacing with 7 minus x. Okay? So, let's rewrite that bottom equation. My bottom equation is x plus 3 times y. What did I just say y was? 7 minus x. So notice it's x plus 3 times y, or 7 minus x, equals 7. You have an equation with x. How do I solve for x? What's step 1? Ian? Okay. We have to distribute the 3. So x plus 3 times 7 is 21. 3 times minus x, minus 3x, equals 7. What's my next step? Okay. If you look at just the left side, I have an x and a minus 3x. They're on the same side of the equation, so I don't have to do anything fancy. Just put them together. X minus 3x is what? Negative 2x. Because, of course, you guys know this is a 1x, right? So 1x minus 3x is negative 2x. I still have plus 21 equals 7. What do I do to solve? Yeah, if it's negative 2x plus 21, I'm going to subtract 21. So then negative 2x, 21's cancel, equals 7 minus 21 is negative 14. If negative 2x equals negative 14, then we're going to divide by negative 2, and x equals 7, because negative 14 divided by negative 2 is 7. Am I done?
No.
Why am I not done? Yeah. If you go back to our graphs, what kind of answers did we have on the graphs? We have ordered pairs, yes? Folks, if we wanted to, we could be doing this problem via graph right now. That is an option. But I'm trying to teach another method, so we're substituting instead. We have 7. We need to find this is 7 comma what? So, easiest way to find the y value. What would you say, Emily?
Again, the 7 as the x on that top equation.
Okay. So take this x we just found, this 7. Officially, I'm going to say go back and plug it into one of the two original equations. I'm always going to suggest the one that was already x equals or y equals. That's going to be your easiest bit. So we're going to take this equation that was y equals 7 minus x. But then we're going to take this answer of 7 and plug it in. So y equals 7 minus, what's x? 7. What is 7 minus 7? 0. So we know y is 0. Final answer? The ordered pair of 7, 0. Okay. That's a basic substitution problem, right? Okay, let's try another one. X equals 2y minus 5 and 3x minus y equals 5. Step 1. Do you have an equation that is either x equals or y equals? Yes? We have an x equals this time. Can we do that? Yeah. Okay. Look for what's easiest. Don't try and make sure you have a y equals. I've got an x equals. That works just the same. So, since I have an x equals, every place I see n x, I'm going to replace it with 2y minus 5. So my top equation is x equals. Every place in the other equation I see x, replace it. So 3x means 3 times, well, what's x? 2y minus 5. So there's 3x minus y equals 5. Okay, do some solving. First, of course, we need to distribute. 3 times 2y is 6y. Minus 3 times 5 is 15. Minus y equals 5. Now what? On the left, we can do some cleanup. 6y minus 1y is 5y. Minus 15 equals 5. If it's 5y minus 15, I want to add 15 to both sides. Good. 5y equals 20. 5 plus 15 is 20. And then divide by 5. And y is 4. Can I call it quits? I could, but I don't get half credit. So what do I do to continue? Okay. Yeah, officially, go back into one of the original equations and plug in y equals 4. My opinion is always going to be use the x equals or y equals. So the equation is x equals 2y minus 5. I'm going to say x equals 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is 3. Final answer? Three, 4. Okay. So first one was y equals. Second one was x equals. Third one, x plus 2y equals negative 4. 3x minus y equals negative 5. Thoughts? Okay. So yeah, do we have an x equals or y equals right now? Michaela's suggesting we make the top one x equals. Is that the only option? What are you going to say?
Could you, on the bottom one, add the 5 over and then subtract, or switch the 5 and the y. So the y would become positive and the 5 would become positive.
So you'd add y to the right and add 5 to the left.
Yeah.
Would that work as well?
Mm-hmm.
So then you'd have a y equals. Now, in my brain, that's kind of 2 steps and the other one's 1 step.
Yeah.
But here's the deal. To an extent, it's what you see easiest, right? Because what you see easiest is what's going to go best for you. You have to pick an equation and make it x equals or y equals. For the good of the group, I'm going to use the top one and make it x equals. But Thomas, if you want to challenge yourself and meet me in the end your way, see what happens if you want.
I kind of worked ahead.
Okay, so you're already there. Well, let me catch up with everybody. So we're going to pick the top one. The key is if you don't have an equation that's x equals or y equals, you make it happen, right? So we're going to the top one. To move the 2y, I'm going to subtract the 2y over. When I subtract the 2y over, I now have the equation x equals, which way do you guys want me to write this? You want negative 4 minus 2y or negative 2y minus 4? I'll be honest, doesn't matter. I'm not graphing it, so it doesn't matter. I can leave it as negative 4 minus 2y. So what's that mean? Every place I see an x, I'm going to replace it with negative 4 minus 2y. So 3 times x. X is negative 4 minus 2y. Then still minus y equals negative 5, right? 3 times the quantity x minus y equals negative 5. You need to distribute the 3. 3 times negative 4 is negative 12. 3 times minus 2y is minus 6y minus 1y equals negative 5. Now what? Whatever you're doing, you have some like terms, don't you? For me, I have negative 6y minus y. So I'm going to carry my negative 12 down. Negative 6y minus 1y. What's negative 6 minus 1? Yeah. So minus 7y equals negative 5. If I'm trying to solve for y, I'm going to move the minus 12, so I'm going to add 12. Negative 7y equals negative 5 plus 12 is positive 7. If it's negative 7y, I'm going to divide by negative 7, and y is negative 1. Okay, is your y and that's my y. Okay, that's all that matters, right? Now what? Take that value and plug it in. I know I say plug it into one of the originals, but folks, wherever your x equals or y equals is. Okay, if you made a mistake in the original solving for x, the mistake's just going to carry through. It's not going to matter at this point. So x equals negative 4 minus 2 times y, negative 1. Negative 4 Minus 2 times minus 1 is plus 2. And negative 4 plus 2 is negative 2. Final answer. Negative 2, negative 1. Did you make it? However, whatever method you took, right? Or whatever direction you took. Okay. One last one here for today. Okay. What do we need first? We need an x equals or y equals. Most of us are seeing the more obvious one is, let's take this bottom one and divide by 2. Remember, if you divide one part by 2, you divide every part by 2. So then I have, what is this? Y equals 3x minus 1. Okay. Every place I see a y, I'm going to replace it with 3x minus 1. So negative 6, that was right, x plus 2 times y. But y is 3x minus 1 equals 8. What are you doing? Distributing. Negative 6x plus 2 times 3x is 6x. 2 times minus 1 minus 2 equals 8. Negative 6x plus 6x. What'd you say? It is just 0, isn't it? So if that's just 0, that means my x's just canceled. They failed to exist. What's my remaining statement? Negative 2 equals 8. So variables just canceled out, yes? Does negative 2 equal 8? No. Since this is not a true statement and my variables canceled out, what are we going to say? No solution. What would no solution look like if we graphed these two? They wouldn't cross. And what kind of lines don't cross? Parallel lines, yes? Okay. They'd have the same slope. Okay. Now, the other alternative, and it might happen on the back, what if variables canceled out, but then we got a true statement, like 8 equals 8. Okay? All real numbers? Infinite? Okay? I have written down on my paper infinitely many solutions. Okay, there's a lot of different ways to say it, but that's the other alternative. Those two things happen when all variables cancel out. You have to look at what remains, a true or false statement. Okay, homework is out there. If you want to go ahead and work on graphing and substitution, you can. Monday we'll talk elimination. Maybe we'll have some work time. I don't know. We'll see.
So is this homework due in the chapters?
This homework is due when I finish part 1 notes. So it'll probably be due Tuesday.
Okay.
Which